עכשיו הסתדר. Muy, muy.
קווין. סליחה, מה זה זה? ידעתי?
So hello everyone, and thank you for coming. Speaking English, honors of Edmund, joining us from abroad. For those of you who don't know Outbrain, Outbrain is a content discovery platform. We're helping everyone to find the most interesting and relevant content online. Currently serving billions of recommendations every hour with over 500 million unique users a month that are using our recommendations. We see about 80% of the internet traffic in the US is actually going through our systems. So it's a very high-scale, challenging environment. And we've arranged this meetup in order to share with you guys a few words from our own guy Radzi, who will tell you a bit about how we are using Chef at Outbrain. And we'll follow by Edmund, who is a chef expert coming from abroad, now also doing the chef training that we have this week with Naya College. And I will let him introduce himself later on in more details. So without further ado, Guy, the stage is yours.
Woo!
Okay, I'm here to talk about Chef at Outbrain. My name, like Orit said, is Guy Radzi. I work in the Infranet group in operations here in Outbrain. I've been here 1 year. Mostly what we do is we handle the infrastructure and the network, making sure that everybody else in Outbrain can do their job. Among that, we also have the chef we're responsible for the entire infrastructure. And also I support November, as you can see from the mustache. That's great, but it's a very important cause. If you want to look it up, I suggest doing so. This is the ops team from last Purim. This is not how we dressed every day. This is me right here. That's the rest of the team. We try to have a little bit of fun. So our environment. We basically have 3 data centers in the US, roughly around 4,000 servers, all bare metal, all we provision ourselves. Due to the scalability of the system, we gotta have a high resolution of automation, which we use Chef for configuration management to do basically all the packages around the OS, all the third-party installations like Storm, like Kafka, Elasticsearch, and preparing what we call the Outbrain application machines, which is a container, Java container that we put on the machines, also using Chef. This is a picture of our data center in New Jersey. Looks pretty nice. It's much bigger. This is just one of the many cabinets. So, what we do in Infranet, basically, the mission is keep the business running. When I say keep the business running, what I mean is, first and foremost, the business has to work. What that means is basically no outages. Keep the system as stable as possible, avoid as many what we call catastrophic outages, and be able to move fast and run quickly. And this is a picture I took, by the way. We try to keep it as agile as possible. Whatever requirements we get, we need to push them into production quickly, and hopefully without breaking anything up. So how we do it? Basically, we rely on these 3 points. The first one is the most important thing. We gotta make wins. When we put out something to the company, they have to see the benefit they have inside of it. If there's no benefit there, or if the benefit will come in 3 months, they probably will not use it. So when we put something out, we start with a quick win. We want them to be able to see how they use it, and they make a And it makes their life much, much easier. Which relates to the second one, KISS, keep it simple, stupid. Whatever you do, you gotta make sure that people won't have, it won't take them now 2 hours to try and understand how to use your product. Which leads us to the third one, which is productize. Whatever we pull out, whether it be for other groups inside operations or outside in Outbrain, we want to think of them as the clients. Whatever they get, it has to be simple for them, not for us as operations, but for them to use it. So, how we do it? The first thing we talked about is speed, which means that once we get something, we want to be able to push it to production as fast as we can. How we do that? We instated Vagrant in our environment. Before that, what we used to do is test our code in production. Whenever we had a change we want to do in the cookbook, we would upload it to the Chef server. We would try to run the Chef client on one of the machines. It would either work or didn't work. And if we wanted to test it on a new machine, we had to reinstall a bare metal machine from scratch and test it. And if it didn't work, we need to install it again and again. And it made the deployment phase really, really long. So one of the benefits of Vagrant is we created a local environment on your machine where you bring everything up. It's very easy to use. I don't know how many of you know Vagrant, but it's a few simple commands. What we did in Outbrain, this is a snippet of our Vagrant file, which we distributed. Basically, it has two attributes in the beginning, the host name and the run list. That's all you have to set. There is a script get roles, which will bring you all the roles needed from the Chef server. Once you Vagrant up, you have a localized, isolated environment using the cookbooks that you develop on. You want to make a change, you test it on the Vagrant. Then we move on to quality. Once we were able to push the code quickly into production, we found out that's not enough for us. We wanted to be also quality code. So what we did, the first thing we did, is we switched from SVM, which we were before, and moved to Git. We wanted to utilize the Git branches, which lets us first and foremost isolate the development. When somebody used to develop something, we used to develop it on the master branch, which means that everybody got it. Now we're using branches. You're able to create your own branch, work on the feature on it. And only once you are finished and you did all the testing, you merge it back into the master and you move on. One other thing we did there, we had a big repository which included all the cookbooks. So we split it up to a per cookbook repository, which now lets us, first and foremost, do the merges much more sanely. When we had one huge 200 cookbooks repository, any change anybody made would have to be merged later on between the rest of them. Now when it's a per cookbook and everybody works on his own cookbook, it looks much more simpler. And this is a short list of some of the cookbooks in our environment. As you can see, there's plenty of them. This is maybe a third of the cookbooks we have. As you can see, there's a lot of Obi Kafka and Obi Kafka New and U2 and U3, because when you develop on production, if you don't want to break it, you've got to copy it aside. So this is the result. One other thing we added was static analysis. We use Robocop, mostly for linting, indentation. We had a lot of code. It was just unreadable. It wasn't bad code, but it was unreadable. And it comes down to indentation and stuff like that, which we put in. We didn't have written standards of how we write the code. And the code looked like we had no standards. So the first thing we did is we added it to the part of the pipeline. We do not fail for anything, we just give out warnings. You better look at this file, you have a problem here. You better look at that file, we see something wrong. And the first thing we did is we added this food critic rule. This is OB001. It's a very simple food critic rule. What it says is ignore failure, it is set to true. This was very important for me. I don't know how many of you have used Chef, but it has an ignore failure, which you can say true, which basically means I want this code to run, but I don't care if it doesn't run either. Me personally, I haven't found any place where it would fit, so I want to know if somebody puts it in our code. And in our legacy code, it was there quite a lot. This is the legacy cookbook. This is all ignore failure set to true, and there's more above and below. So it makes debugging very, very difficult, since the Chef log is now full of errors. Some of them you care about, some of them you don't. I don't know. If anybody has a place where he thinks ignore failure should be set to true, I would love to hear about it. I haven't found any place where it would fit. And the last thing we did is created a continuous integration environment. which we didn't have before. This is for ops. It's based on Jenkins. We use it for integration testing. We have our base rule, which runs on all machines every half an hour and runs on the Jenkins server every half an hour for all type of OSs. That way we catch a lot of stuff that used to break production. Now we catch them here. We put a continuous restore there, which basically means that every backup we do, we have a build that restores it a few times a day. We use the Vagrant file that I showed you before, bring up the environment, converge the backup, restore it, make sure everything is fine, and we destroy the machine. The last one is the deployment pipeline, which is not yet a part of our CI environment. Today, when we push the code, it goes straight to production, and we should have tested it. We want to put a build process in there, test it before it goes to production, and for that, we're hiring. So, if anybody wants to come work with us, this is one of the tasks that needs to be done. And that's it. Questions?
Thank you, Guy. And for the main course this evening, Edmund.
I have one question.
Yeah.
Jenkins. Do you manage the Jenkins jobs already with Chef too, or is this a
No.
manual thing?
It's a manual thing. We build our own infrastructure based on a few common scripts.
Okay.
And we have one job that prepares the VM, takes the Vagrant file and brings it up and prepares it, registers it to the Chef server and everything.
Okay.
And then there's a job that runs and does whatever it needs.
Okay.
And we use the snapshots to every time revert it back and run it again, revert it back and run it again. Currently, we don't have that many builds in Jenkins. This is something we will probably need to maybe find a different scheduler once we scale it up a bit.
Okay.
But currently, we have, I don't know, around 12 builds. We don't really have that much of a problem yet.
So maybe you should have a look at Chef Delivery. It's a cool thing. So I'm not employed by Chef, but it's a cool product.
So I got the mail about the webinar today. This is yours.
Yeah.
Clicker.
Sorry?
The clicker.
Oh, the clicker.
I will just hit my keyboard. I'm not so fancy at the
Ah ouais. צנוע.
So, first of all, thanks for inviting me here. It's nice to visit Israel, my first time in Israel. Yeah, cool. I read a lot about partying people in Israel, and I went to some club on, what was it, Saturday evening, and Sunday is a working day, the start of the week, right? Yeah. And you're in the middle of the people, 3 in the morning, and they're all partying, and you think, this is not able to work out. You would not, I would not be able to do that. So there's my first question. When do you sleep then?
Whoa.
At work.
When?
At work.
At work? No. So, my name is Edmund Haselwanter. I always get the, where is the extended display wrong? Maybe make it a little bit bigger. So this is one of my beloved quotes. There is the question from Captain Kirk and Scotty. Scotty, she's all yours, sir, all systems automated and ready. A chimpanzee and 2 trainees could run her. So that's one of the goals. Gather all the information you have about systems, put them into place, and the system will know what to do. Today we will have, so another thing about me, I'm running chef trainings in the German-speaking area of Europe. So whenever there is another opportunity, some people at Chef are reaching out to me, do you want to go to Israel? And I said, well, never been to Israel. This might be a cool opportunity. So Israel is the farthest south I have been, and Iceland is the farthest north I have been up until now on the behalf of the company Chef. And it's really cool to use that tool. Our focus today, or my focus today, is when I get the right thing. So here, mouse pointer, testing infrastructure. So we already have heard there is the need for running some kind of test. So you are now happy to write some code, you run that code, it builds up the infrastructure, and maybe that's a good point in time to have a look what can we do to ensure that the code we have written for our infrastructure is do what it's supposed to do. There's one thing, now we are trying to apply a lot of this software development stuff right to infrastructure too. So what we need to do is, in the terms of Chef, we need to write cookbooks. In Puppet, it's libraries. In Ansible, whatever you name that, or SaltStack, it's always the same. And then you try or need to have something you can run, probably in a CI, to test your code. This presentation is part of the training I'm doing, where we span everything from infrastructure as a service to testing applications. So sometimes there are a few statements which really don't apply to this session, but we learned in the training how to test code with Cucumber. So we have Cucumber and Gherkin to describe tests for the application code. And here we dive right into, we have written the code for infrastructure and we want to test that too. So just testing the application is not enough anymore. We need to test the outcome of the deployment. We need to test infrastructure too. Our infrastructure deserves tests too. What was an old way of doing it? Maybe you had a checklist. Is the service installed? Is the configuration looking okay? Quality assurance engineers looking at the final configuration, and that's it. That has been a long way of doing this kind of stuff. And we heard already from the presentation before, we test in production, right? So that's what we have done. And we want to stop doing that. Another thing, we already have configuration management to speed up the stuff. So maybe a few years ago it was possible to rack up a new server. First you order it, then you rack it up, then you have some system administration guy putting whatever is needed to run a service on that node, and this took weeks. Testing, you could have another few weeks, because weeks is not a problem. But now we are moving somewhere where you have a server in just a few seconds or minutes the most. Then you have configuration management, minutes the most, and it's deployed. So we need some sort of automation for the testing part too. We cannot spend hours to find out whether the configuration we put on the server is good enough. And the other thing, we want to increase quality too. So there is a good reason about thinking, well, can I do something about this manual testing? And can I put something in there for automating that testing? And yes, you can. That's why we are talking about. What do we possibly need to do? Basically, we want to have a it's working, it's not working decision. Success or failure. That's the basic outcome. If you think in the future, you want to have a CI/CD system, and this needs to make a decision whether it's good to go or not good to go. So we need tooling, probably giving us success or failure. And a few years ago, I think it's a few people in the chef community came up with the idea, well, let's build on top of this Vagrant stuff. Vagrant is an awesome piece of technology, abstracting away, describing this is the server. So many RAM, a little bit of network, and you do not create a virtual machine anymore. You have this in code, you run Vagrant up, and the machine is here. What about extending that kind of thing into the testing space? Is it possible to do some additional ideas around that? And the people came out with, they called it Test Kitchen, to fit into this chef naming scheme, I guess. So Test Kitchen, a kitchen where we can test our chef configuration management code. Test Kitchen is a very cool project, once again, not a chef thing per se, it came out of the community. And it abstracted one level up what Vagrant gave us. So in in Test Kitchen, we have drivers, we have provisioners, we have platforms, and we have test suites. That's it. That's the top level. Test Kitchen can be seen as a test harness tool to execute our provision the machine and run a test after that. You can, since it abstracts whatever you want to run the systems on, there is a part where you have to decide whether you want to run it on your local notebook, that's working, or you're instrumenting infrastructure as a service. You can instrument EC2, Rackspace, OpenStack, whatever. You can piggyback on top of Vagrant, and whatever Vagrant is giving you, you can use that one. And you even can use containers. So you could use, for instance, Docker to further speed up the testing, because starting a Docker container much faster than starting up a virtual machine. So that's possible. And the other thing we want to do is we need to express ourselves in terms of tests. We need some frameworks to express what we want to check for. There is a quite extensive idea about that. There is basically a little bit of glue code. It takes whatever you want to have your test firmware, installs that on the machine, copies over your test code and runs the test code. What's implemented at the moment, BATS. BATS is a bash testing framework for the nerds who really want to go down to the bash scripting, or SH unit, RSpec, very famous, and on top of RSpec there's another one, ServerSpec. ServerSpec is DSL, domain-specific language, on top of RSpec. RSpec is a domain-specific language in Ruby to express tests. Since it came out from the chef community, first-class citizen always has been chef. So you have everything at your disposal to say, so this is my cookbooks I need. It integrates nicely with Workshelf. Workshelf, for those who don't know, is a tool to do dependency resolution in Chef. It will set up everything so you are testing the right cookbooks. And it knows about roles. You can use Chef Zero, the in-memory Chef server. Everything right from the start. So what does Test Kitchen give us? It simplifies all this boilerplate stuff. It simplifies this, I need to bring up a machine. I need to provision that machine. I need to install my testing, whatever software. I need to run my tests against this provisioned machine. It does this by having a lot of convention over configuration parts, and we will dive right into that one. So what we want to do with this is we want to set up Test Kitchen so that we can run chef cookbooks in a virtual machine and run some tests after we have deployed the chef convergence on those nodes. So this is BDD, behavior-driven inspired. What we want to do basically is we want to come up with some kind of behavior of the final machine or machines. We want to write some tests. We want to see it fail. So this is more the workflow part. Then we write the code to make it pass and use the red-green factor. Basically, this is what we do. We do some idea of this is the service I want to deploy. There should be an Apache running. It should serve an HTTP page when I connect with curl to that service. I hop into this DDD. I develop my cookbook. I use Chef Spec or whatever unit testing framework you have for your provisioning. And once I'm satisfied with that, I'm going to hop out into the BDD cycle, provision a real operating system with that, or lots of operating systems, and see whether still everything works out. How does this relate to OpenStack or any other infrastructure as a service thing? Well, OpenStack gives us infrastructure as a service. We can say, give me a new machine with that size in that network and I want to be able to connect to it. You can use EC2, you can use Vagrant with a local box, you can use Docker. Test Kitchen with the configuration can be seen as kind of an orchestrator which is opinionated against this testing workflow. Spin up a machine, provision it, install the Chef, the testing framework, run the tests, and give some feedback about whether it's good or not. In my training here, I use OpenStack as the infrastructure as a service, as the part which provides me the execution environment, Chef as the config management system, and Service Spec for the integration testing. Test Kitchen in itself lets you switch out OpenStack for EC2, whatever you want. It lets you switch out even Chef for Puppet or Ansible. So in another project, there is a reference coming up. We used at Deutsche Telekom, we started to have a look at can we provide hardening for servers in configuration management. So they have a lot of PDF documents stating what a server needs to look like. In a SSH configuration, you need to have this cipher disabled, for instance. And we implemented that in Chef and Puppet as a proof of concept, and we have written all the tests in Server Spec. You could switch out Server Spec with any other testing framework you would like. You just need to provide an installing and an executing hook. Real world example, as I mentioned, Telecom Laboratories, automatic server hardening, project sponsored by Deutsche Telekom. We had half a year to come up with a rough implementation for their I want to check automatically for their this is the checklist, and if you fulfill that, you are good to go. We always knew that you cannot really have this automatically tested for everything, but we aimed for the low-hanging fruits. I already heard that. So you easily can automate 80% of this stuff, and we did. So it was really successful. It was so successful, the guys on this project created a startup named that Vulkanosec, iterated on that idea for another more than half a year. I think it was 9 months or so, and Chef bought that company. So the new Chef what is it, compliance tool is based on these things, on these learnings. So how does it work? Describe your infrastructure with Chef cookbooks, with Puppet, with whatever provisioning you want to do. Define your testing suites, this operating system with these tests, come up with that and define what you accept and what you not accept. And the cool thing kicks in here, so maybe this is not really a requirement of yours, but for us it was a requirement to be able to have a real test matrix. Yes?
I didn't understand what tests are agnostics to provisioning means.
Tests are agnostic to provisioning in the sense of you have your configuration management system and you describe in whatever language you have at your disposal the deployment. And you never ever want to have your testing description dependent on what you used in the provisioning part. So for instance, if I use chef, I do not want to use chef to describe the test. I want something else. That was very important for us. To be able to reuse that, for instance, with Puppet. So it's separate. Agnostic meaning I do not depend. For me it's, you can have it installed manually if you want to. I don't care.
Good, thanks.
What we did in this project was we used Chef and Puppet, and we had a few focus areas: base operating system hardening, SSH hardening, Apache hardening, all the obvious candidates. And we needed to test for a few operating systems and a few major releases of those operating systems, major and minor. And Test Kitchen gives you really what you need in order to be able to do that. So the whole project has been done with Test Kitchen, Chef, Puppet. I think there is Ansible already, Ansible or SourceStack, and the tests have been written in ServerSpec. So a little bit, how does it look like? What do we need to do is get Test Kitchen. We can Chef gem install Test Kitchen. It's already part of Chef DK. 2 days ago I have seen there is Ansible or SaltStack DK already, including Test Kitchen. So this is really a thing for other people too. They're dependent on Chef. Then we have the kitchen command at our disposal. What else do we need? In this example, a cookbook. If you're not familiar with Chef, I just dive through it. You don't really need to understand the details of a cookbook. Just as much, we have a cookbook in there, and the cookbook is supposed to install JIT in this example. We place our configuration management code into the recipe, and we then initiate a default configuration for the provider we want to use, in this case OpenStack. This will create us a kitchen YAML file, and in this file you have to specify details for the driver, details for the transport, details for the provisioner, details for the platforms you want to test against, and details about the test suites. So this translates nicely into run list and configuration values, and I want to use this role and stuff like that. Here in the provisioner section you say I want to use Chef 0 or Puppet apply or whatever command you need to run for the appliance, and in the driver section you specify I want to use EC2, these are my credentials, or OpenStack, for instance. Proxy server, not important. So the driver lets us switch out whatever we want to use. There is a discovery for a lot of different drivers. So I already mentioned, EC2 comes out of the box, OpenStack. Vagrant if you want to run it on your local notebook. The other section is provisioner. Here you tie up whatever thing you want to use to actually configure the machine. Chef 0 for us in this example, could be Puppet or something else. Then platforms. So this ties into, I want to test this on Ubuntu 12.04, Ubuntu 14.04. You specify all the operating system versions you want to have. And test suites. Test suites is run this configuration and run these tests. With test suites, you can easily come up with a lot of testing if you want to. Check out config. If you run kitchen list with just one test suite and one operating system, you get this line. If you do it for more sophisticated testing, so I just got the idea, maybe I can show you something. Just a second. I did. So, for instance, not really super up-to-date version, but Chef is using this too. And this, for instance, is the test configuration for the MySQL. Sorry? Sure. Sure. So they have specified a much more complicated thing than I have in the presentation. Here we have vagrant, then we have provision of chef 0, that's the same thing, and then we have platforms and run list, and platform and run list, and platform and run list. Sometimes we have a special driver configuration. Sometimes we need to include something. Sometimes we need to specify very special attributes to be working with that one. But finally, we get a description of just a bit. 82 different combinations of operating and test suite, right? So a simple YAML file expressing an awful lot of, I want to test that one. Or if you have one operating system and one test suite, that's how you start out. It's just one line. This is manageable by the notebook. The other one, you want to have infrastructure as a service. 82 servers running, it's not so lightweight. What does Test Kitchen do? I introduced it as an opinionated orchestrator for testing, and that's exactly what it does. It has a lot of distinct steps you go through. The first thing you need is, now I'm starting to not just talking, but let you talk a little bit for me. The first thing you need is a machine, an instance, something where you can run your provision on. There is a distinct step for that. It's kitchen create, name of test suite. This will spin up a machine with the exact configuration derived from the configuration. So what you basically do is, you have your workstation, you do kitchen create for all the 82, or kitchen create for the name. It will spin up a machine for you. This machine is ready to use.
Does the create also provision it, or just create?
Create is just creating. Create is just creating. Then we have a new last action created. So this machine is up and running. In this example, we want to test whether we have installed the JIT correctly. First, we need a part in the configuration management to be able to say install that. That's quite easy in Chef, it's just packaged JIT. And the provisioning step is called converge. Kitchen converge, name of the test suite, will run whatever provisioner you have specified on that machine you created. If you did not have created a machine before, it will do both steps, create and provision. So what happens? It will create the instance already done or do it. It will push the cookbooks in the current state and all the dependencies on the machine, and it will run the Chef client on that machine, or Puppet or whatever.
Is it using Chef server? Chef 0 as a server?
Yes.
Yes.
You can specify solo or solo. You even can specify
You
server.
can manipulate the data of this server?
You can, with Chef 0, you just lay it down on your file system.
Yeah, but I mean, you can describe nodes that do not exist just for the cookbooks to run.
Yes, you can. You put down a JSON file, this gets uploaded to the in-memory Chef server, you can do a search against that. You can. Too many commands? Well, it tries to abstract away the concrete commands. I have started to just use the test kitchen interface to do quite anything. So under the hood, I'm still using Vagrant, for instance, but most of the time I'm using it through Test Kitchen because it gives me everything I want, including testing. You will see that in a minute. So it abstracts how to get to this instance. It's always the same. It's create, whether it's EC2 or OpenStack or just a VirtualBox instance, it's always create. So all kitchen commands facilitate OpenStack and Chef commands or EC2 or whatever you need. This would translate to Nova Boot or whatever you use to spin up an EC2 instance. The converge would do create me that instance, a knife bootstrap, if you have ever used that one, a Chef client run to get the idea. So this abstracts away the underlying command and it's platform independent. So what else do we need to do? Up until now we just have a very convenient way to spin up a machine and provision it, but that was not the goal. We wanted to be able to express a test. How can we sure to be that JIT is installed? Basically, you could have a checklist or any kind of, I log into this server, I run git ---- version, and if it gives me something back, I have installed it. But this does not really scale. Have people log into a machine to check out whether it's working or not? That's not good. And it's not working with CI either. So we want to do exactly this. By the way, there is a login, so abstracted away the login, you just do kitchen login, machine, test suite, and it's doing everything else for you. So we want to be able to express this one. Okay, login, not so interesting. It uses a transport, you can configure the transport, SSH, but we are, after this one, writing a test. We want to now leverage some testing frameworks to express ourselves in, do we actually install JIT on that machine? There is a cool framework on top of RSpec. Who has never heard about RSpec? Everybody has. Yes. Okay, there is server spec. It sits on top of RSpec. It gives you additional primitive to describe instance. What can you do? You can express resources once again and what state they should be in. write a test for that. You don't need really an agent. It would run over SSH. In this case, it's installed on the machine and it runs on localhost. And this is basically how it looks like. So it looks quite similar to what you're used to have in your whatever configuration management system. It gives you a high-level language to describe tests. So package is part of server spec. This is given you by server spec. Describe is coming from our spec. So we have a lot of matchers. It should be installed. This is coming from the RSpec framework. Package, for instance, is coming from server spec. And this is looking quite nice to me to express there should be a package NTP installed. The service NTP should be running, or the client of that, and there should be a configuration file on that location containing those lines of code. And you can run that on CI now with thumbs up or down. So we need to do that, the same thing for our Git cookbook. We place, I already said, configuration over convention over configuration. We have a directory test, then we have a directory integration, and within that we choose a name matching the test suite. We choose a name matching the test framework, and we put all the testing files in there. And this is how we would do this kitchen login and test whether Git is installed or not. Use server spec, use the backend exec, describe Git. There should be a package Git installed, and if I run which Git, the output in standard out should match user bin Git. That's it. Now we can throw it at our CI, or we can run the command here on the command line. Kitchen verify will run all the tests against our installed machine. So kitchen verify, update our testing stuff and run tests. Verify in itself will not reprovision. You need to take care about reprovisioning, so you change your provisioning code. You need to reprovision and then run the tests. We should see our tests pass now. Kitchen verify can be run from nothing to this point. It would create a machine, provision the machine, test the machine, and give us some output, whether it's working or not. Current state, verified. And with that, you can get super fancy. And maybe
Can you enlarge it?
sorry?
Zoom in.
Zoom in.
Zoom out so you can see the entire picture.
Thanks.
So it worked before. Yes, switching off network, switching on network is not a nice idea for vagrant. So maybe I got confused now. As you can see, a few minutes ago I used the full cycle of it. It's starting here. I did kitchen verify. It started a new machine, default Ubuntu 12.4. It installed all the dependencies with Workshelf. It uploaded everything. It created a Chef 0. It synchronized the cookbooks. It was compiling the cookbooks of my run list. It ran the Chef client on that node, and it ran the testing after that. And let's try. So every presentation has to fail, forcing shutdown. So this time, we start from the beginning, so I just kitchen destroyed my testing environment, and then I said run it from the beginning and verify once again. It brought up a new clean machine. It created a virtual machine in Vagrant, VirtualBox that is at the moment. It configured that you need to be able to SSH into this one, booting the machine up, going in there, fetching down the Chef client installation, and so this could be optimized with some caching, so you could place your download or installation of Chef client either into the image if you don't want to, or if you don't have to have a lot of different Chef clients, or you can optimize it by using some kind of cache layer, a varnish or whatever cache or something like Oculus. So it does not have to go throughout the internet. So this is running against the internet now, fetching the Chef package to install that one. It updated the cookbooks to run. It configured the Chef client to run this test suite run list against the node. It has been an empty node, and whatever is in there. And whatever is in there, we can have a look at that. So Apple is kind of shit sometimes, I have to admit. It's always stealing the main. Okay, here, interesting. Here I said use service spec. It figured out on its own what it needs to do in order to be able to use server spec. It installs the server spec thing on the target. There is a new tooling upcoming, it's called inspec. So from the hardening project I told you, from this Vulkanosec company, they have reiterated over the whole thing server spec and re-implemented that one. And they now don't require anymore that you install server spec. They have a new executable which gets installed with your DK, and it will go over a transport, SSH in most cases, to the target machine. Nothing needed to be installed on the target, and run the tests. So what did we test? So this is one of the examples. Description, driver Vagrant, provisional Chef 0, platform Ubuntu 12.4, test suites default. So when I say kitchen list here, it tells me, oh, there's one verified. If I go in here and try to do something, so some people at the project management or whatever told me, get your shit running on the next major release. I add one line, I say kitchen list, I have another one, I say kitchen verify, and I've never run that actually. But this is how easy it would be to say, oh, there's a new major version of the operating system. Let's find out whether we are able to run that on that operating system. Changing one line of code. It's creating a new base image, running a new one, setting up networking, and doing everything we did before. And I wonder if that will work. I don't think so. Never tested it.
If your tests involve other machines, that's
Yes.
communication between other machines to understand if the service is working, how would you suggest to do that?
That's still a real problem. At the moment, I'm working around that by piggybacking on test suites. So what I do most of the time is I'm misusing test suites. So I'm describing a bunch of servers working together and name test suite 1 web frontend, test suite 2 web backend, spin them up together, keep in mind that they both need to be running so that everything is okay. So I need some kind of orchestration bringing them up.
You run them in parallel?
Yes.
At the same time?
Yes. And for instance, with Vagrant or other backend providers, you even can specify the IP address. So you can misuse that all the time. In one of the last projects, I misused it for, you can use Vagrant to give people a kind of interaction environment. So in one of my last projects, I specified Test Kitchen. I did an all-in-one deployment of their Java application, handed that over, and they are doing Kitchen Verify with the EC2 driver, and that spins up a new machine on EC2, sets up DNS configuration, and they can interact with their application. Everything configuration management, everything needed to set it up, it's one command.
Can they use the same Chef Zero, or that's not possible?
For that I'm using Chef Zero.
I mean that both Vagrant machine
No.
applies to a single Chef Zero?
Never tried that one. That would be some funny interaction. Never tried it.
So you know if they plan to give multiple machine support in the future?
There are plans, but I don't know how far they got. So it's always, your mileage may vary, and they tried to, so there is, within Chef, there's Chef provisioning. So you can have cookbooks to describe a whole infrastructure fleet. And there are prototype implementations to use provisioning as the driver part. So you basically set up your environment, and on top of that you run the Chef client against the created
Yeah,
machines.
but then Chef provisioning needs to support your provider, right?
Yes, but there are plenty implementations for that already. And there is always the fallback to SSH once more. So it worked. So my cookbook is working on Ubuntu 14.4.2. Testing it on CentOS, another line. This one won't work. What did it test? Well, this one is making it bigger once again. Unfortunately, I can only make the text bigger, but not the sidebar. So what does it do? It uses apt, it installs HAProxy, software load balancer, it uses a configuration for that one, it uses search, so here you have search, it's Chef Zero. You need to come up with fake nodes in order to be able to get a result, but you can do that. See, there is test, and somewhere down there you put that, somewhere down there. So you have to find out what is a good way. Most of the time you want to have it somewhere near your test suite, because most of the time it really depends on what you want to test. What do we want to test is here server spec. This is the only thing needed. So we need directory structure test, integration default server spec. This is matching what we have in the YAML file. And here is the spec. Service should be blah, 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 blah. And then we can make it break intentionally by saying whatever. And then we can verify once again. I don't know if this dot no worked. So I said it should match, but it didn't. It should match. So this was just a thing to show you that it actually tests something. Everything green, well, that's literally not so. If you can I use that framework now a lot in the development cycle. So I spin up a machine, I get my chef code, my ideas ready, I implement that, I run kitchen converge and kitchen test and kitchen verify, kitchen converge, kitchen verify. And you iterate on that one, so this is super cool during development. And then there's my final step where I say destroy, bring up a new one. This is kitchen destroy, kitchen verify one again. And if this one gives me everything is cool, I push to version control. And I run Rubocop and Food Critic before that too, obviously. Can this be any easier? Yes, it can. You can run kitchen test either with a test suite or with nothing. Kitchen test will come back with return value 0 if everything worked. Return value different from 0 if there has been an error. And this is the thing we are aiming for, CI, acting on the result of our test. So you can throw this right into your check-ins, spin up the machines, 82 machines somewhere, and get feedback about your shitty test here or shitty configuration code you have written. What does it do? Kitchen test ensures that you have a pristine state. It will destroy all instances if there are instances. Then it will create fresh instances from the configuration. It will push out and run your configuration management system, whatever it is. It will run the Chef client or Puppet or whatever you want it to run. It will upload and run the testing, server spec or whatever you want it to run. It will run the test and delete the instance. If you do not specify, keep the failing ones running if you want to inspect that, maybe, I don't know. Default, throw them away. So, and the rest in the slide deck is basically the same thing. So what can we do? We can extend something, we can add another platform, we can try another operating system version, and basically you iterate on that one, you add some additional code. In this case, we add a new test. We want to install a daemon. It needs to run on port number. There has to be a service which should be running, and you leverage that and you fix it by installing it with your configuration management code. So this basically resembles kind of everything I wanted to tell you about kitchen and test. Any questions left? Or is it already boring? No questions. I did talk too much.
It's just Israeli techies are too shy.
No, they are not. I've learned about that.
Just the first one.
Israelis are very direct, so hit me. Nothing to add. Well done. Thanks for your attention. Maybe, and it's really a cool tooling to do all this stuff. You should definitely look into it. It's open source, so there's no harm. Thank you.
Thank you very much. It was a real treat to have you with us.
Thank you.
And thank you for coming. And enjoy the drinks and t-shirts. And we hope to see you again in our next meetups.